So this video reviews how to switch between mixed numbers and improper fractions. More often than not, whenever you see a mixed number, you are going to be turning it into an improper fraction and or leaving answers as improper fractions. It is very rare that we actually work with mixed numbers. In certain contexts, mixed numbers do make sense. For example, if we were talking about ordering pizza and we had sort of did a calculation where we wanted to figure out how much pizza was eaten, it might make more sense to say that, for example, between a bunch of people, we ate 2 3/4 of a pizza instead of saying that we ate 11 1/4 of a pizza. So depending on the context, mixed numbers do make a lot of sense. But in terms of working with fractions and trying to make things a little bit easier in terms of calculations, improper fractions are often the best way to go. And so what we're going to do first is just look at how we convert between. So if you were given an improper fraction and you had to turn it into a mixed number for, as I said, an example like I just gave in terms of a context, what you would want to do is you would want to figure out how many times the denominator goes into the numerator. So for example, how many times does 5 go into 12? So 5 goes into 12 2 times. And then you would ask yourself, what would the remainder be? So 5 times 2 is 10, and so that means the remainder is 2. And so then you just write the remainder as a fraction, and your answer would be 2 2/5. The second example, same thing. How many times does 4 go into 21? 4 goes into 21 5 times. What would the remainder be? The remainder would be 1/4. Let's look at the opposite, which is often what you're going to have to be doing. So in the opposite, what you're going to have to be doing is turning mixed fractions into improper fractions. So it's kind of the reverse of what we just did, and actually this one is a silly example because it's the exact same one above, but we'll go through it anyway. So what you do is you 2 wholes times 5 pieces would end up being 10 plus 2 extra, the 2 remainder, would end up being 12/5. And then we do the same thing over here. The larger number, the whole number 3, multiply that by the denominator, 7. So 3 times 7 is 21. And then we're going to add what was left over, the 6. So 21 plus 6 is 27. And we're going to keep our denominator the same. And so that's how you are changing from a mixed to an improper. You're taking the larger, the whole number, multiplying it by the denominator and adding the numerator, and then writing the whole fraction over the denominator. So let's just look at a couple examples of why we would want to use that. Again, it's going to make our life a little bit easier in terms of calculations. So for example, in this one here, the very first thing, anytime you see mixed numbers, the very first thing that you're going to do is turn them into improper fractions. So 3 times 8 is 20. So 3 times 8 is 24, plus 1 is 25/8. And 2 times 4 is 8, plus 1 is 9/4. And then you're just going to do exactly what you would do with any other subtraction problem. So you're going to get a common denominator, which in this case will be 8. Remember, whatever you do to the bottom, you do to the top. And then you would simplify that to 7/8. This one, again, same thing. We're going to turn it into an improper fraction first. So 5 times 5 is 25, plus 3 is 28. 2 times 6 is 12, plus 1 is 13. If you would like here, because those are really large numbers, 28 times 13 is maybe perhaps a little difficult to do in your head, you could cancel here. So for example, 2 goes into 6 3 times, and 2 goes into 28 14 times. Now, I mean, you're still going to end up with a difficult multiplication here, and so you might want to be using your calculator. But the canceling does help you and tries to make things a little bit more simple for you. And so 14 times 13 is 182. And 5 times 3 is 15. And again, you would just leave your answer like that. You could check, obviously, if that simplifies, but through this cancellation process that I used here, I know that I've canceled things first, and so I don't need to worry about simplifying. And then the final one, again, like division, we want to make sure we changed everything into improper first. So 3 times 4 is 12, plus 3 is 15. And then we're going to multiply by the reciprocal. And then we're going to look to see if we can cancel. And be really careful here. There is a 5 and a 15, but you have to cancel top and bottom. Remember, numerator and denominator. So you're going to end up canceling if you want to. That's how you're going to do your canceling. Then you'll end up with 25 over 4. And again, you can leave your answer like that. Again, you don't have to do the canceling. You can just multiply the numerators, multiply the denominators, and simplify at the end. It can just make your life a little bit easier in terms of working with smaller